everyone. In this video, we are going to continue our discussion about the gradient of a vector, and we will learn about a new operator, that is the del operator. So let us first understand that what was gradient of a vector. In the last class or in the last video, I told you that this is delta t, the gradient of vector t is something like dt upon dx x cap plus dt upon dy y cap plus dt upon dz z cap. Now this can be rewritten as d x cap d upon dx plus y cap d upon dy plus z cap d upon dz and t. I hope you understand till now. Now this thing which is written in the bracket x cap d upon dx plus y cap d upon dy plus z cap d upon dz, this particular thing, this entire thing which is written in the bracket is known as del operator, and we use this del operator in different ways to give us different ideas about a particular vector or a scalar function. Like t was a scalar function, and when we took the product of del vector and this scalar, then what did we get? We did get the direction in which maximum increase of function t will happen. We got the direction in which maximum increase of function t will happen. Now there are three ways in which we can use the del operator. The first was with the scalar function, like in this way. The second way is taking its dot product with some vector function. What's the second way? Taking its dot product with some vector function, let it be v. So what it would yield in this case, this is a vector, so it would yield a scalar. And what is this? The del operator taken dot product with a vector it gives us divergence of any particular vector. What does this give? This gives us the divergence of a vector. This gives us the divergence of vector v. In the similar way, if we take the cross product of any vector with this del operator, if we take the cross product of any vector v with this del operator, then it would definitely give us a vector. And what does this vector give? This vector gives us the curl. This vector gives us the curl. Now the question comes that what is the meaning of divergence and curl? So the meaning of divergence and curl is that divergence is the measure of how much vector v spreads out from the point in question. Suppose you have to find divergence at some point x, y and z, or x naught, y naught and z naught. Then how much the vector v diverges from this point. How much vector v diverges from this point. Diverges from this point will be given by the dot product of del function and dot product of del operator and v vector. So how much vector v diverges from this particular point. I hope it's clear now. You will ask me that what is the meaning of curl. So the meaning of curl is how much the vector v swirls around the point in question. So let this again be the point. So if we find its del operator along with a cross product, so what do we get? How much the v vector swirls around, how much the v vector swirls around the given point. What does the meaning of swirl here means? Suppose this is the point, suppose this is a particular point x naught, y naught and z naught. So how much it is moving, how much it is swirling according to this particular point is what we would get when we take the del operator and its cross product with vector v. I hope it's clear till now. Now I will give you one short way to find the curl of any vector. Since taking the curl of vector would be a quite tiring process, because these two are vectors and taking cross product of vectors could be quite tiring process. So let me make it short for you. We will use the same method that we used earlier for taking out the vector product. In this, what we would do is that x cap, y cap, z cap, okay, and d upon dx, d upon dy, and d upon dz. And in the lowermost corner, in the lowermost row, what we would write vx, vy, vz. And I hope all of you know that from where this vx, vy and vz comes. It is from the vector v. From the vector v, which is vx x cap plus vy y cap plus vz z cap. I hope it's clear till now. Now, this is the way this determinant will give us the curl of the vector. I hope that it's clear till now. So let's recap what we have studied till now. We have studied the del operators and we have understood that how the del operator acts when we take its dot product with another vector, when we take its cross product with some other vector. Now let me ask you a question. Let me ask you a question that says, let me turn the page and there will be a question for you. And the question is something like, find a vector function that has zero divergence and zero curl everywhere. So what you have to do, you have to find a vector function. So the question here says that find a vector function. Find a vector function which has zero divergence and zero curl everywhere. Zero divergence and zero curl everywhere. Zero curl everywhere. I hope it's clear to you. Now, this is something which you have to do by yourself. So try this and see whether you can do this or not. Now, the next thing that we move on is the product rules in differentiation. As in the last lecture, we had started differential calculus, which is going to help us in the understanding of electrodynamics. So we are going to continue with the product rules in differential calculus. So let us write the heading, that is product rules. Please try this question. If you are not able to do it, you can comment down and I will make a solution video for this question. Now let's write the next heading, that is product rules. That is product rules. Okay, I hope it's clear to you. Product rules, addition rules and subtraction rules, we are going to understand all of them in this particular topic. Now, what does this topic say? Suppose we have to take derivative d upon dx of some function f plus g. So what we would do, we can separate them and we can find something like df upon dx plus dg upon dx. I hope it's clear. Similar thing we can do with subtraction. Now, suppose we have to find something like d upon dx of some function f which is multiplied by a scalar c. So we can multiply by c the derivative of this function x and both of them would result in same values. I hope that it's clear till now. Now, next we move on to the product rule. D upon dx fg. Now, this will give us f dg upon dx plus g df upon dx. I hope it's clear to you. We will also see some examples, so don't worry about that. Now, the next thing is the division rule. So, d upon dx, some function f divided by g. So, how would we find the derivative of this particular function? So, we would do f dg upon dx minus g df upon dx, which will be divided by g square. So, keep this in mind. This is something over here which you must keep in your mind. Now, let me give you a simple question. Let me give you a question which says some function fx is equal to x square plus 5x and some function gx is equal to x cube plus 4. So what you have to do, you have to find d upon dx of fg. This is something in question, and you have to find d upon dx f upon g, and you also have to verify this. You have to verify this by formula. So what you have to do is that verify both of them by formula. Both of them. So you have to verify both of them with the help of formula. I hope it's clear. Try this on your own. In the next lecture, we will start by discussing this particular problem. I hope that this video was clear to you. If you have any doubts, you can put it in the comment section. I would be really happy to help. Thank you very much for watching.